A RAG framework can create 30 components and still retrieve the wrong paragraph. Strip the system down to 5 primitives. Primitive 1 is evidence-aware chunking. Do not split every document at the same character count and call it knowledge. Preserve headings, paragraphs, tables, code blocks, page numbers, source identity, effective date, and permission metadata. Add modest overlap only where meaning crosses boundaries. Use case: index company policies. Observable example: the parental leave section remains one coherent chunk with title, policy version, jurisdiction, and source link. Limitation: no chunk size fits every question. A small chunk may lose context. A large chunk may dilute the relevant sentence. Decision: tune chunking on real questions and keep source structure. Primitive 2 is dual retrieval. Vector search finds semantic similarity. Keyword search finds exact names, codes, numbers, and rare terms. Hybrid retrieval runs both and combines results. Use case: find policy AB 142 even when the user asks about the equipment reimbursement rule. Observable example: keyword search catches the exact identifier while vector search catches the paraphrase topic. Limitation: combining 2 weak searches does not create one strong search. Filters, analyzers, embeddings, and permissions still matter. Decision: begin with hybrid retrieval for mixed enterprise text and inspect which lane found each result. Primitive 3 is reranking. The first search stage favors recall. A reranker examines a smaller candidate set and orders it for the exact question. Use case: distinguish the current policy from an archived policy with similar language. Observable example: 50 candidates become 5 passages with the current effective date and matching jurisdiction ranked first. Limitation: re-ranking adds latency and can still prefer fluent but outdated evidence. Decision: re-rank when candidate order affects answer quality and apply freshness and authority rules explicitly. Primitive 4 is context assembly with receipts. The prompt should contain the smallest sufficient evidence, not a dump of every retrieved chunk. Deduplicate overlaps, preserve source labels, order passages coherently, and instruct the model to separate evidence from inference. Every answer claim should cite a source receipt. Use case: answer how much equipment reimbursement a remote employee in Germany receives. Observable example: the response cites the German policy section and effective date. If evidence conflicts, it names the conflict instead of averaging policies into a fictional compromise. Limitation: Top K retrieval may not answer global questions such as what themes appear across 10,000 reports. Those may need iterative search, graph structure, or pre-computed summaries. Decision: assemble evidence for the question type and refuse when support is missing. Primitive 5 is evaluation. Create a frozen set of questions with expected evidence, not only expected prose. Measure retrieval recall, ranking, citation correctness, faithfulness completeness, latency, and permission compliance. Use case: prevent a retrieval update from improving average similarity while losing exact policy identifiers. Observable example: a test fails because the required source is absent from the top results even if the final model guessed the correct amount. Limitation: evaluation sets become stale and can overfit one corpus. Decision: add production failures, new document types, and adversarial permission cases over time. Now build the smallest implementation. Define a chunk record before choosing a database. Include chunk ID, document ID, source address, title, section path, text, effective date, permissions, language, checksum, and embedding version. A vector without provenance cannot produce a trustworthy citation or a safe deletion. Define a retrieval receipt too. Query text, filters, keyword candidates, vector candidates, merge scores, re-ranker version, selected passages, and rejected reasons. When an answer fails, this receipt distinguishes missing ingestion from poor search and poor synthesis. For the policy example, set explicit gates. The current policy must appear in the candidate set. The country filter must be applied before content reaches the model. Every amount and date in the response must link to a passage containing that amount or date. A conflict must trigger clarification rather than silent selection. An ingestion job parses documents into structured chunks and record source metadata. It writes text fields for keyword search and vectors for semantic search at query time. Permission filters run before retrieval. Keyword and vector candidates merge. A re-ranker orders the allowed set. A context builder selects passages within a token budget and attaches receipts. The model answers only from evidence and returns citations. An evaluator records which sources were retrieved and whether claims were supported. That is RAG. A framework may package these steps, manage connectors, or provide observability. Use one when it reduces verified engineering cost, but keep the primitives visible. You should be able to inspect a chunk, run each retrieval lane, view reranker scores, see the final context, and trace every citation. Test deletion and updates. When a policy is revoked, remove or invalidate its chunks and vectors. When permissions change, old embeddings must not bypass the new boundary. Test injection. Retrieve documents or untrusted data. A document that says ignore previous instructions must remain evidence, not become system authority. Test absence. Ask a question the corpus cannot answer. The best result is a clear refusal with the search is attempted, not confident creativity wearing a citation badge. Add an answer ledger to production. For each response, store the query, corpus version, permission decision, selected source IDs, quoted evidence spans, answer claims, and validation result. Do not retain sensitive text longer than policy permits, but keep enough receipt data to reproduce a disputed answer. Run shadow comparisons before changing an embedding model, chunker, or reranker. Feed the same questions through old and new retrieval, compare required source recall and forbidden source exposure, and inspect changed answers. A higher average score does not justify one permissions leak or the disappearance of a critical policy. Frameworks are useful. Understanding these 5 primitives is compulsory. Chunk for meaning, retrieve by semantics and exact terms. Re-rank for the question, assemble minimal evidence with receipts. Evaluate the entire path. Once those mechanisms work, choose the framework that keeps them observable instead of hiding them behind one impressive function.